Howdy. So you're probably wondering what cattle and exponential functions have to do with each other. Graphing of them in particular. Well, let me tell you a story about this. I grew up on a ranch in southwest Montana, and we had to punch cows a lot. And I'm going to let that story hang as a cliffhanger for you as we approach this here problem. So let's graph, say, the function f of x equals 2 to the x. Alright? Now, notice this is not x squared, so we're not looking at a parabola in this instance. So what we're going to look at, let's do this the long way. This drives me nuts. I hate doing this the long way because there's a shorter way that I'm going to show you in a minute to do these. So I'm going to pick some x values here. -2, -1, 0, 1, 2. I'll throw in a 3 there just for good measure. Now if we plug in a -2 into that exponent, that's 2 raised to the -2, which is 1 over 2 to the squared power, which is 1/4. So when x is -2, y is going to be 1/4. Let me graph what I've got here. Set up a little Cartesian coordinate grid. So when x is -2, y is 1/4. So we're right about here. Now I'll do the same thing for when x is -1. I'll go 2 to the -1. That's 1/2, right? So when x is -1, my y value is 1/2. So you can't really see much of a change there yet. Hang on. 2 to the 0, hopefully that's a no-brainer. That's 1. So when x is 0, y is 1. I'm going to make that a bigger dot there. Whoops, and that orange on it. Now 2 to the first power, hopefully you understand what's happening there. That's 2. And 2 squared is 4. 2 to the cubed power is not 6, it's 8. Well, so let me plot those points. When x is 1, y is 2. I'll make that a bigger dot for a reason. And when x is 2, y is 4. So I'm up here. And when x is 3, y is 9. So as you can see, this thing's really starting to take off. So that's the graph right there that you're looking at. F of x equals 2 to the x. Now as you can look at this, you're going to see this barrier here. This graph, as it moves to the left, the smaller your x values, the more negative your x values are becoming here, the smaller your y values. But notice your y values are not going negative. So they're going to hug this x-axis, if you will. This is what's called an asymptote, this here barrier. It's an asymptote, it's a barrier. So I always like to think about when we were herding cattle back when I was a kid. What we would do is we'd get all the cows and we'd push them against the fence, and then cows are dumb. I'm sorry if you're a cow lover, but they're really dumb. They'll follow that fence, and yeah, there's always 1 or 2 that will go through the hole, but for the most part, they'll follow that fence line, and it makes it a lot easier to push those cows, but they don't cross that fence for the most part. And that's what that barrier is serving in this case. We've got this graph. As it goes more and more negative, the x direction, this value is getting closer and closer, but it will never cross that 0 barrier. Okay? It's just going to hug it. So when you graph your exponential equations, make sure to never let it cross that barrier, because if it does, well, then you're going to get it wrong. Okay? Nope. Now, I'm going to make another video here in a second that'll show a faster way of being able to graph this exponential equation.